are some examples that we're going to use in this law of sines section. Here's a right triangle. We have the adjacent leg. We want the hypotenuse. So we could use sine. Sine of 40 is going to equal our adjacent 6 over the hypotenuse x. Variables on the bottom, so we can divide. 6 divided by sine of 40. We're going to type that in, and that'll be the length of our hypotenuse. (9.33). And this is a rounded answer, 9.33. It is not 9.33. I just made a huge mistake here. I used sine. That's the adjacent leg, and that's the hypotenuse. I should not be using sine. I should be using cosine. Hopefully you caught me there. If you didn't, shame on you. Should be cosine here, boys and girls. So what is 6 divided by cosine 40? 7.83. That is the answer that we're looking for, 7.83. That's a straight mark. Sorry about that. That's how you use your right triangle trigonometry to find that length. Now, we just learned the law of sines. Could you use a law of sines here? Well, we want this side, x. Notice how it's across from a 90-degree angle. Side length divided by sine of the angle opposite of it. Here's a side length. Divide that by the sine of the angle that's opposite of it. We know that's 50. Cross multiply. So I'm multiplying 6 times the sine of 90, and then I'm going to divide by the sine of 50. What do you think that's going to give you? It gives you the same 7.83. Which way do you like better? Well, you're probably more accustomed to this, but this might be more fresh in your mind. This is probably more efficient, but this way works too. So we were talking about law of sines helping you to find measures in acute or obtuse triangles. Well, the law of sines still works in a right triangle too, just like your right triangle trigonometry. Number 8, a little bit different. We want this side length. We have that angle measure. So write it up here. Oh, that's an A. That's a really bad A. That might look like a 9. That's an A. A over sine of 55. We have that side length and we have the angle opposite of it. That's going to equal this side length. Oh, and of course it's a 9, right? 9 divided by the sine of the angle opposite of it. The only problem is we don't know this angle. Okay, well, we can find it. If that's 103, we can find that angle by subtracting 103 and 55. Remember the triangle exterior angle theorem? And there's other ways to do it, but this ends up being a 48-degree angle. These two angles, remember, have to add together to give you that one. So that's the key there. So you're using that 48-degree angle because it's across from that 9-foot length side. And there's your proportion. I will switch my colors here. We're going to do 9 times the sine of 55, and we're going to divide by the sine of 48. And that'll be your length for that segment A. 9 sine 55 divided by sine of 48. 9.92. That's how long this side is.